In this video, I will be showing you how to run our ATPG project, or uh, automatic test generation project. First, you need to install all of the requirements. You could do that with pip install -r requirements.txt. I already have all of the requirements, so it's not necessary for me, but if you don't have the Z-tree solver, you will need to run the pip install. The next step is for us to run the main entry point, which is at python source index.py, and then you could optionally specify a benchmark file. This could be any path, but the preferred path is benchmark file. Let's load 21, and then let me exit the program again. Or if you preloaded the netlist that you want to test into the benchmark, you could simply run python source index.py. As noted before, all of the options below option 2 are optional, but just for ease of use, let's run them. Okay, this parses the primary inputs, the primary outputs, and gates, and it loads to an output file. This output file is the main reporting. This is the master reporting file. So after running each command, you will need to check this outputs folder, parse that text. It has a definition of all of the gates, the inputs to the gate, as well as its output, the primary and inputs and primary outputs. And then you press enter, it resets. If we perform fault collapsing, we'll get 2 fault, and we'll get 3 files. The total list of faults, which are all faults in the system. You'll also get the collapse.txt, which defines the faults. So you have a total of 24 faults. The equivalent fault classes removed are 10, with additional 4 dominant fault classes removed. These show equivalence. This fault is equivalent to these faults, and etc. And also it shows the dominance rule. So this fault dominates this fault. Note that there are some equivalence relations happening in this domination list. So if one gate dominates 10, the 10 gate stuck at 1, there could be an equivalence with another fault within the list that also dominates another one. So for brevity, just list the main dominating fault. We could also list the fault classes here simply in the console. There is also the collapse faults folder. This just shows the final set of faults. As you can see, there are 10 faults after collapsing this circuit. Next, we could move on to simulations. So that's menu item 3. Here, I enabled that you could simulate all single socket faults. So let's try this. And then you specify the input vector. Since this is a 5-bit vector, we input 5 sets of binary values. Now we could check our simulation folder with the output. Now it's simulated for all of the classes using the specified vector. As you can see, it shows all of the expected and observed, the detected faults, from the simulation as well as the undetected faults. And it also has a table summary here that has the good circuit, the inputs, the outputs, and all of the faults, their inputs and the outputs as well for you to review. For simulation, there's also another option, manually select a single socket fault. So here you would select a gate. Let's say, well, let's take a look at our collapse fault list first. Okay, so the one gate stuck at 1 is a fault within the system. It doesn't have to be from the list of collapse fault, but it just makes more sense for us to simulate a fault from the collapse list. So one gate, and then we put the stuck at value 1. Please note to specify the gate based on their actual net name. Their net names are before the SA value. And then I'll just press enter to continue. Now I enter the input vector. Now if I go back to my simulation, you'll see it's a lot more concise because it doesn't have all of the test vectors. Similarly, if I simulate and go to manual and I don't specify a fault and I enter an input vector, it will just show me the good circuit, how the expected results from a circuit. Moving on, we have our tests. So if we were to generate the algorithm, again, I could target a specific fault, but in this case, it makes more sense for me to just cover the entire list of faults because this is the automatic test generation. So I'll select option 2, and then I go to the algorithm, and here I see all of the test vectors, the input vector, and other faults that this input vector also detects. Moving on to PODEM, I select the option for PODEM. I run automatic. Again, the vectors are stored here. These are the specific fault. These are the input vectors. And these are the additional faults that that input vector detects. Lastly, the Boolean satisfiability. Follow the same process. And then, as you see, there's a sample. It's not all of the faults that were detected. But if we go to the SAT folder, we'll see the full list of detected faults and input vector. Thank you for taking your time to watch this video.